Hey everyone, thank you so much for checking out the Weaviate podcast. Today I'm here with Vincent Warmerdam, an engineer at Explosion AI, which is a part of Spacey. And Vincent is working on some really exciting things with nearest neighbor search and the things that we're interested in at Weaviate. So, Vincent, thank you so much for coming on the podcast. And can you tell us about the things that you're doing with nearest neighbor search?
Sure. Thanks for the introduction. So there's a couple of experiments that I'm doing. Part of those are related to this tool that we make. Prodigy, you might have heard of it. It's a labeling tool. And I have recently found out that for some of my experiments, it really helps to have a good approximate nearest neighbor lookup around. There's two areas that I was pleasantly surprised where it worked quite well. So one area is in the case of data deduplication. Turns out you can do a couple of really neat tricks there. But I also noticed that if you are starting with labeling, let's say an NLP data set, there's also a couple of tricks that you could do with an approximate nearest neighbor lookup. So part of my work, what I do is I do a little bit of research, a little bit of customer support, doing lots of things over at that company. But usually whenever I do a little bit of research, that also results in a plugin or a blog post. And recently I've also been making some YouTube videos on this stuff. So yeah, I've been surprised at how flexible approximate nearest neighbor lookup tables are for a really broad set of applications. But the main thing that I thought was interesting is data deduplication and labeling weren't the most natural candidates that came up in my mind. So yeah, that was a pleasant surprise.
Yeah, I think this is super interesting at looking at how we can do this nearest neighbor search from just the obvious match the query with the documents thing and how we can look at these. We'll dive into these two ideas of data deduplication and then bulk data labeling or say weak supervision. And we'll have that. Let's maybe start with data deduplication. Can you tell me about the general kind of setup of this problem?
Yeah, so let's say that you have a questionnaire, and there's a name and there's an address and zip code. I don't know, some information. Let's say, and let's say that in this questionnaire, I may have gotten interviewed twice, but in one situation, my name got misspelled.
Mm-hmm.
Okay, so that's a very clear example of a misspelling should not indicate a separate entity in a database. So probably this has to get merged. And you say this, and you kind of go okay, questionnaires are kind of cute, but does it have business applications? Um, and then you learn very quickly that when banks merge, for example, their customer profiles also need to merge. And it would be a shame if, let's say, the same mortgage appears in the data set 5 times. So this is a genuinely important business case. Um, but then you kind of think okay, what are the standard ways of solving this? And you can go with the rule-based system direction. You can kind of say, well, let's only look at people in the same zip code. And then if the strings are similar enough of the name, we can make a little candidate list. And that's actually a fair approach that will work for a large chunk of the data, but probably not all, because you have high precision, but maybe not the highest recall when you do that. But then if you start thinking, well, maybe we can do a little encoding trick where we say, let's take a name of a person and let's take 3 grams, like the characters, so to say. So Vin and then INE, and you basically encode it that way. You get this little sparse array. And then even if it's spelled slightly differently, the sparse arrays will still be somewhat similar because there still will be a bit of overlap with all these character engrams. So that can get you thinking, hey, maybe we can encode some of these categorical variables as text with just a sparse encoding. And then if we just index all of that and we have a new candidate and we just say, look, this new candidate, is there a duplicate of it? Just fetch the 10 nearest items. And if there's a duplicate, it's probably in that set of 10 items. And of course, you can do fancier things if you're dealing with text. Similarly, you can also use embeddings, let's say. But I've noticed just with some of these sparse tricks, like the sparse embedding ones, the results were quite reasonable. Which you can do some fancy things, like you can also do thresholding, right? So you can look at the distance of the items that you get back, and you can kind of say, well, only look at the items where the distance is this big or this small, etc. And I was actually pleasantly surprised how easy it is to set such a thing up, and also that it kind of just works. The way that you encode things, especially if it's like names and you're mainly concerned about spelling, the standard encodings for sparse stuff really lends itself well for these kinds of lookups. So it was a very pleasant surprise. If folks are interested, this is something I'm also exploring on the YouTube channel using Prodigy. But just the whole idea of maybe doing data deduplication this way, I think is very powerful.
Yeah, so it's so when I hear data deduplication, I think of it maybe usually from the perspective of, say, you're training a language model and you get internet scale text and you want to deduplicate repeat instances, or I guess generally looking at data sets where you don't want to have the same instance repeated twice, because maybe with the kind of bias of gradient descent, it's going to be overfit to that particular kind of thing. But it sounds like you're coming at it from the perspective of, say, knowledge graph construction, or this kind of
Or
uh,
customer databases, yeah, like a little bit more in that realm. Yeah.
yeah, really interesting. It's a really interesting way to kind of summarize the data set too, by merging similar vectors. How does this differ from, say, like a k-means kind of clustering sort of, compared to just kind of like merging it down with the semantic categories?
I mean, so the down like, k-means is not an unreasonable idea, right? But you do immediately hit the issue of how big should k be? Like that's kind of like, okay, like you solve one problem, but you also introduce another one, and you simply don't have that if you just have a sensible way of encoding things. And again, it depends a bit on what your concern is, right? So if spelling errors are your concern, then sparse encoding is like the obvious way to go about it. If sentiment is more your concern and it's like a bit of written text, and maybe you're a bit more interested in bot behavior, let's say, like, hey, is there someone who wrote nearly the same thing? Then at some point, language models and text embeddings, those things become a bit more interesting. Um, but one thing that I realized as I was sort of doing this work is if you have a tabular data set, let's say, so names and addresses, or a graph, right, in different nodes, you can choose to encode each column differently. So you are free to say, like, okay, but this is a user with a name. Okay, that's going to be sparsely encoded. And what the user is saying, right, that can be with dense models. And you just concatenate the two. Maybe do something more fancy with like dimensionality reduction as a post-processing thing. But that also can just still be indexed. Like that's also like an aspect of like deduplication with approximate nearest neighbors that I think is pretty interesting too. You can use the same column in two different encodings. You can encode each column differently, and you can actually use a fair amount of domain knowledge to sort of steer the algorithm the way that you like.
Mm. So I think there's a lot to that in this. So we're getting on the idea of how we encode the data, how we produce the representations, and this idea of, say, sparse representations, which are, say, like BM25, TF-IDF, or say the count
Or just ones and
vectorizers.
zeros, yeah. Yep.
Yeah, yeah. And fusing that with the vector representations that come from usually sentence transformers, I think, is what we're thinking about with text and dense passage retrieval, these kinds of ideas, and fusing those two. So maybe we could go a little further on this idea of how are you thinking about the combination of sparse representations that are usually based on some kind of keyword
Mm-hmm.
counting, what, like how, and I think they vary mostly in how the vocabulary is constructed, and then fusing it with these dense retrieval methods.
Yeah, so that great question because a lot of what you're mentioning there is a bit of an unsolved problem because you can go ahead and just concatenate the two, right? You can say, "Oh, I'll just concatenate the sparse stuff with the dense stuff," and you can wonder, well, what kind of effect will that have for like distance measures? Is the distance measure that I'm interested in for like the text, is that going to be different than the distance measure for like the users? It might start getting a bit tricky. One thing you can do though, and this is like maybe not step one per se, but maybe step two. So let's say step one is the simple trick of just sparse vectors for now. But by doing this, we have actually been labeling too, right? So, okay, this was an actual duplicate, this wasn't, and this was an actual duplicate, and this wasn't. Okay, the moment that we have a couple of these examples, then we can say, okay, part of my input is sparse, part of my input is dense. I'm going to put a dense layer behind that, and then I'm going to have after that like an actual label that I'm going to try to predict. I think this might be the neatest way to sort of merge the two together because then at least there's some sort of a signal from your label determining what the next layer should be, and then you can use that hidden layer as your next embedding for your lookup, so to say.
Yeah,
And
sorry.
so that's an approach that I think is quite reasonable. But it does, of course, always depend on your data, how many columns you have, etc.
Yeah, maybe we could stay on that a little more. The idea of you have your, say, BM25 representation, and then you have the representation that comes from one of these sentence transformers. So we have two vector representations, and then say we want to put that into another dense layer that is going to do the, say, we could call this multimodal fusion if we like.
Sure.
maybe
Yeah, that's sure.
some phrase like that.
Yeah, some phrase, right? Yeah.
Yeah. So what would that architecture look like? We have the two vectors. Should we maybe, would it be like an attention layer in that? Like, because we could have the MLP where we just concatenate the vectors. Like, if you imagine my
I mean,
left
so
arm,
like, I mean, so I would start simple, really, right? I mean, especially because in the beginning you're not going to have millions of data points, right? So then keeping it lightweight is probably the most reasonable way to go about it. Um, and also the thing, like, if you want to do stuff with attention, typically you also need to have an extra tokenizer involved, and the order of the tokens might start to matter and stuff. So it's not just more vectors; it's also some of that stuff you got to keep in mind. And again, like my vantage point at the moment is a little bit more that I have a table with many columns, and then for one column I suddenly need a tokenizer, and for the other one I don't. So to keep things simple, I would just keep it fast forward and dense. And also, like a thing that I've noticed with this deduplication stuff, at least on the data sets that I've been demoing on, imagine that we're actually doing this for like a bank, let's say. We're trying to merge customers together. And then at some point, it turns out that for some people, there's like a typo in their social security number, let's say. But for other people, it's just a completely different number, like obviously a different number. Okay, yeah, maybe that's a duplicate, but that also should be flagged for fraud, right? So the business case also, whenever you're doing something with deduplication, there's a lot of the time, I would say, maybe also like a fraud angle involved. And because you're then also in the realm of multiple targets that you might be interested in, right? Then you kind of want to have a neural network maybe with two output nodes. And then, again, keeping it simple with just the dense layer, I would argue is probably the first thing you want to do.
Yeah, I'm really happy you brought the banking data set idea into the picture because I think our conversation is getting into that realm where having a data set really would help communicate this idea. So the data set to me that jumps out the most, and I'd love to get your comments on this, is the Cora question pairs of duplicate questions. But maybe it's not long enough. I know those questions are usually only like 10 words long, and as I've been studying vector search with Weaviate, I've seen like big and maybe not like massive inputs, but only 10 words long is not great for this idea of we're going to combine BM25 and DPR and have another dense layer on that. It's not really the best data set for that. So maybe another example, and again, the banking example is great, although I think I'd like to first start with something that's purely text for drawing this idea of how we do this. So maybe we could use the same heuristic they use in Wikipedia, where to train the sentence transformers, they use the heuristic of neighboring paragraphs are going to be positives.
Yeah.
So, and it gives us a good sequence length of say like 200 tokens, so we can combine BM25 and DPR in a meaningful way. So say we take the Wikipedia data, train test split, and then we have our BM25 of each paragraph and our sentence transformer embedding, and then we train our, the dense fusion layer on top of that to have the agreement. Do you think that would be a good example of tying this together?
Yeah, so my background's not really in search so much. So what I'm going to attempt now is a little bit of a guessing game, and someone who's more knowledgeable might be able to sort of tell me that I should read another paper. But just pragmatically, whenever you're going to be doing some merging, right? Can we guarantee that the labels are of high quality? Because we are probably going to have to say, like, okay, we have to be super sure that this is an actual answer to that question, or we have to be super sure that this definitely isn't an actual answer to that question. And because we're dealing with language, there can be a whole lot of nuance, right? And my impression is that there's a very similar problem in the realm of like queries. So this one query that a user typed, and then the user then clicked this one other thing, while what the user have also clicked something else. You don't always know. So I think from my perspective, the issue is maybe not so much the architecture that I would be primarily concerned with, but maybe more just the data quality. Like, am I really, really sure that I have meaningful labels that can actually propagate some sort of knowledge into these layers? Having said that, the moment that you are sure about your layers, then it's much easier to iterate because then you can trust your metrics a bit more as well. But especially if you're just getting started with this deduplication stuff, I would be more worried about that. Like, are we sure it's a fraud case? Are we really, really sure it's an actual duplication, or is there actually a person who lives in the same street who just has a slightly different name? Because that also happens sometimes.
Yeah. The part of encoding it is so interesting, and maybe quickly before we go into the bulk data labeling as well, could you expand on the idea of the indexer half of this? One of the most interesting parts of Weaviate is the HNSW built in, the approximate nearest neighbor benchmarking and that whole world. Could you tell me how like that kind of approximate nearest neighbor search for, say, large scale deduplication, what that kind of picture looks like?
Well, so like, usually you get started on a small set, right? And that's also something I've noticed with the ANNOY library. The ANNOY library is quite good, but the moment the data sets get a fair bit bigger, you're going to want to start adding more trees quickly. like, I used to be a bit more positive about this, but especially like I've noticed it with word embeddings as well. You might want to have 10,000 trees, like, which feels a bit much, but that might actually be quite reasonable. Um, so the main thing from my perspective, at least, because I'm more interested in data quality, whatever ANN solution I have, I kind of don't want to think about it too much. So I do think that the stuff that I've been using so far is in the realm of medium data. And for those sorts of things, like in-memory stuff, like ANN, PineN descent, those things kind of work. But I do know if I'm going to go bigger, then I need like something of a more formal, like proper database solution. And I can definitely imagine Weaviate being a tool to consider there. Yeah.
Yeah, quickly before, could we stay on the 10,000 trees and maybe explain to our listeners a little more about how the ANNOY algorithm works for dividing up the space? So to me, ANNOY is very similar to like binary search trees. It's just instead of a scalar greater than or less than, it's like a hyperplane that divides this n-dimensional space. And
Yes.
so it's a stochastic algorithm too. So you have 10,000. So could you explain further how you get to
So
10,000?
I could be somewhat wrong, but my impression of the algorithm, at least, is you just pick two random points, and you to make a plane between those two random points, and boom, that's your first cut. And then from each leaf there, you repeat. And basically, you do this a whole bunch of times, and then you have one tree. And then, binary tree, so the lookup in the space can be quite fast. And okay, you can do that with one tree, but then the odds of you being in a leaf and then missing a couple of interesting neighbors is quite big. So you know what we do? We make a second one of these trees, or maybe a third, and then we put that in kind of an ensemble to figure out who the nearest neighbor should be. And on smaller data sets, you might be able to get away with 10 of these trees, but for larger ones, I've noticed you definitely might want to increase the number of trees, just because otherwise it gets quite approximate. I will say, like, ANNOY is pretty quick when it comes to indexing. Like, that's something I did notice. It was actually, like, I think it's written in C++ as well, so it's actually quite fast. But you do want to keep an eye on this one hyperparameter. That's one thing I've noticed. You should not blindly assume that 10 trees is enough, because once it gets bigger, it just isn't.
So you ensemble the nearest neighbors from 10,000 trees to get all of the potential duplicates in the data?
I believe that's what they do, but I could be mistaken because I didn't check the C++ source code to know for sure. But I believe this is the approach that they do. Yes, yes.
Yeah, it's really fascinating. I love thinking about this idea of how the deduplication, finding nearest neighbors, and then how you do it at a very large scale. I think that's really interesting. And maybe quickly we could kind of just entertain this idea around deduplication for language modeling data. Have you thought about that kind of thing, and do you think that's interesting?
Yeah, so before I used to work at Raza, and this was actually kind of a pretty big topic there. Like, hey, when can we understand when someone is saying gibberish, like something we've really never seen before? And
Mm,
but the very simple conclusion I just keep hitting my head on is just that language is hard. There's
mm,
a book from Emily Bender, which is a little bit more about linguistics for people who are doing NLP. And the first chapter just nails it on the head on this topic. A language is more than just a bag of words. If I take the sentence "a lion eats a man," and I take another sentence, "a man eats a lion," one of those two sentences feels a bit more probable than the other one. But how am I going to teach an algorithm that? Right?
right.
And then language is also like a moving target. And then we've got internet slang. And oh, can we also detect sarcasm and emotion? And it's really just a hard problem. So the way that I would approach this is to just remind yourself that the learning is really in the labels. If you want your algorithm to have certain behavior, just make sure that that behavior is really encoded nicely in the labels itself. Um, and that's where language models, although they're quite useful, you're usually predicting like a masked token or something like that. And
Mhm.
you can wonder, well, is that really the pattern that you're interested in your application? Most of the time, it isn't. And that's why, especially we at Explosion, with a tool like Prodigy, we really advocate for like focusing on the labels. That's probably where you can steer the algorithm the most.
Mm. Yeah,
And language is hard, by the way. And language is really, really hard. That's also like
that's
the reminder that I keep getting when working in this field.
Yeah, that notion of language is hard, and I love that you brought up that work from Emily Bender, and it reminds me of a paper from Emily Bender and Alexander Kohler. I think it's titled something like "On Meaning, Form, and Understanding in NLU,"
That
and she
sounds like an Emily Bender paper. Yes.
it's a great paper.
Yeah.
It really helped me think clearly about this, and let me quickly tell you a story from the paper that I think really does this well. The anecdote is this: there are two, say it's me and Vincent, we're stranded on islands, and we've got an underwater cable that takes from my island to Vincent's island.
Hmm.
And I'm saying, and I'm describing the island to Vincent, there's palm trees, sand, and we're passing language through this cable. And as the anecdote in the paper goes, there's an octopus that is.
Oh yeah, I think I vaguely do go on, but I vaguely remember this now. Yeah.
Yeah. So the octopus is intercepting what we're saying. And so the octopus sees our messages and it learns how to, cut the cable, talk to Connor, talk to Vincent, and Vincent and I don't know if it's each other or it's the octopus. But now you get in, I like to think of this as an out of distribution event or a domain shift event where suddenly there's a bear on my island. I'm like, Vincent, help me, there's a bear.
Yeah.
I'm
And
trying to
how's the
realize
octopus supposed to know what a bear is? Yeah.
yeah.
Yeah. No. In general, Emily Bender has a lot of these arguments that are like. So I'm also, that's also the thing. I don't know what your background is, but I'm not a linguist. Like I was dyslexic. I used to hate languages when I was in high school. Now I've gotten more of an appreciation for it. But I've always noticed, like also with some of my colleagues, if they have a linguistic background, there's just so much more of a radar for these sorts of, hey, language is actually really hard, that this can also be happening. Um, but yeah, no, I do remember that paper. Emily Bender is worth keeping an eye on because of these kinds of papers. She also did the stochastic. She was part of the stochastic parrots one as well, I think, right?
I know I should be, but I'm not like terribly familiar with that one.
No, but there's a bunch of super influential papers. I'll say that
Yeah,
she's been working on. But yeah.
Yeah, there's definitely a lot to language in it, and it does make it things like adding symbolic structure with like syntax trees. I think all of that kind of stuff could be really interesting, and maybe I think a nice transition from here to kind of some topics in Weaviate for our listeners is I really like the graph-like data model and things like semantic relations and ontologies. So, kind of maybe to me, one way to bridge the linguist's knowledge and then make it sort of amenable to deep learning techniques would be to do these ontologies and have semantic relations between data. Have you thought about that kind of thing? Of say, maybe to draw an example, if I'm modeling my Twitter data, I might have tweets, and then it has the content of the tweet, and then it has article, and then this article is this other kind of object that has the content of an article. And that's an okay relationship idea of this. Another probably better example would
Sure.
be these biomedical knowledge graphs, where you start off with the knowledge graph where you have like drug has target, has binding target, and then so you create the ontology that way, and then you put text information that describes the genes, describes the targets, describes say these pathways, things like that. So I guess the question and the conversation topic would be, have you thought about semantic web ontologies, named relations as a way of adding linguistic style symbolic structure into the way that we're doing NLP?
So I've dabbled with this, but very, very briefly. And I have colleagues who are way more knowledgeable about this than I am. The only thing, like from I will argue that I'm the novice here, but from my novice perspective, one thing that I'm really charmed by when I hear these sorts of things is I can imagine that if you have a graph structure, you can put a lot of domain knowledge in, and that's actually quite useful. Like just in general, the computer is the octopus who doesn't know what a bear is, but at least you can tell the graph that a bear is a mammal and dangerous and hungry, like stuff like that, for example, right? And that's already nudging the algorithm it feels like you might be adding a nice little constraint to your system. And now graphs, on the other hand, are also still graphs, so they're not necessarily they can be complex too, right? So you're also introducing maybe some complexity, but just that aspect of like, but we could put domain knowledge in. That seems very useful to me, for sure.
And so that domain knowledge interface could be useful for de-duplication, because with similarity labeling, right, you end up with a graph where you're saying this is similar to this thing, it's also similar to this thing. So maybe we could talk about the idea, and coming back to labeling too, I think it ties it together, like how do we label similarity?
Ah, that's the eternal question that we've not solved yet, I think. But like the way I like to think about it, at least, is again sort of coming back to the whole idea of the learning is in the labels. So I was talking to a retailer the other day who had a very interesting one. So when we are out of normal spaghetti, what is a good replacement product? Well, to some people, it is going to be another pasta, like any other kind of pasta. But to other people, it has to be spaghetti. So I'll just get like the whole oats, like the super fibrous spaghetti instead. Okay, who's right? Well, the similarity is in the eye of the beholder in a way, right? Like it depends on the use case too. And you can also imagine that like if you have kids, for example, the little shape of the pasta also matters because kids are stubborn. They will only eat the one pasta in a certain type of shape. And the food analogy, but similarity is really also kind of an opinion if you think about it. So the way I just really like to think about that is just, okay, we have some sort of business case. We try to define it as clearly as possible, and then we try to label with like in a consistent way, and we try to achieve some sort of a consensus. There's a lot of interesting work also happening in this space. If you want to have a fun look, there is the Google Emotions dataset. The data set has lots of interesting label errors, at least from my perspective. But the interesting thing is they also have the annotators in there. So you can actually track, like, hey, when do annotators disagree? A ton, turns out. And especially in the realm of emotion detection, right? When is it sarcasm? When is it humor? When is it actual joy? When is it actual anger? A lot of that is dependent on culture, which is really dependent on where you live. So it's not necessarily a surprise that even if you are a fluent English speaker, but you live in the other side of the world and you're 40, that you're not going to understand what 20-year-olds in the US are posting on Reddit, for example, or not perfectly at least. And no one should be able to blame you for it. And I think the best example I had while researching this, folks who are interested, there's a YouTube video I made for Prodigy on the techniques that I use, but there was one, oh my God, those tiny shoes, I want to boop its snoot. Like that was like the sentence. And then the question is this about excitement? I would argue it is. So, like, booping a snoot sounds like there's a photo of a pet somewhere and someone wants to gently touch its nose. So that sounds like excitement to me. But I can't blame anyone for not understanding what booping a snoot is, right? That's kind of like internet slang in a way. So there you already kind of go. Like, what is similarity? Well, I would argue it's similar if a label says it is. But hopefully the way that we encode it correlates with it. And that's kind of useful when we have a nearest neighbor lookup. So let's say I have a whole bunch of Reddit data. I'm just going to use whatever featureizer, whatever transformer, just sort of index it. And odds are, if I can just have one sentence about a topic that I'm interested in, kind of zero shot, I am going to get examples from my actual data set that are, at least to some extent, similar. So if I'm, let's say, doing social media analysis and I have a support desk for a local retailer. Then if my delivery is late, then I can just type my delivery is late and code that. And hopefully what I get back are things that are in some sense similar. But then you label, and then you might get a better embedding. So then you index it again. And then you get into this little kind of weird active learning loop where you have a model that makes better embeddings, which you can actually use to reindex. And hopefully by just iterating on this, you're not just iterating on your model, you're also iterating on your data. And that hopefully is going to lead to like a very tight definition of similarity. That's at least how I like to think about it, at least.
Yeah, and I'm so excited to get into that loop of active learning, weak supervision, and how, say, Weaviate and vector embeddings can help with that. Quickly, I want to just tell a little more about the annotation disagreement. I was very curious in this idea of semantic relations when I first saw Weaviate, and to me, the idea of vector embeddings and also adding the kind of named relation thing wasn't an obvious connection. I asked Bob about it, and Bob told me the story that he was at a semantic web conference, and they were building ontologies, and they couldn't agree on what a sea was or a lake. Like, to us, it's a sea, this is a lake to us. And it's that kind of disagreement in the relations that I think that these embeddings let you really capture. Because you can have two labels where, coming back to your example, it's sarcasm or it's excitement. You can't really read it, but you can have the two labels, and it can kind of optimize for both the labels and capture the semantics that it could be either thing in that vector representation. And then you have this general idea of annotation disagreement with human labeling. I think there's a lot to that, especially when you're labeling really complex things, like say you're annotating scientific papers. And
so there's a paper. I hope I pronounced his name correctly. There's a bunch of authors, but Yoav Goldberg. I forget his last name. Terribly sorry. But the paper's title is something along the lines of, "Are we annotating the task? Oh, sorry, are we predicting the task, or are we predicting the annotator?" Which is a really good question if you think about it. Turns out a lot of the annotated data sets out there, not at all of them, but like a good chunk of them, you can kind of wonder, well, how's the annotation imbalance? Is it like the 20/80 rule where maybe 20% of the annotators annotated like 80% of the... Yeah, okay, turns out for a bunch of data sets, this is kind of happening. So then you can ask the question, can we maybe predict who annotated this thing? Or can we make a prediction per annotator? So then the model output becomes not just, hey, what label is this, but what would this annotator give for this label? So the paper makes a point here to say, like, hey, the label's not perfect. That's a genuine concern. But another way that I like to think about it, it would be kind of nice in production if we could say, hey, the model's just kind of not sure. So like won't predict. It's kind of like a flag that we can do. We're only going to be automating when we're actually sure about our prediction. And now suddenly, if you have, let's say, 20 annotators that you're kind of predicting, and let's assume for all intents and use cases that you're going to do that pretty accurately, then the moment that, not all predictions agree, that would imply that maybe you're able to model that annotators wouldn't agree. And that might mean that in production, you should raise the won't predict flag.
Yeah, that's brilliant. That sounds like a really exciting idea to me. And maybe like a well-annotated data set is one in which you can't predict the annotator.
Well, so annotation's hard, right? But genuinely, it's much harder than I thought. And also, back when I gave trainings in data science, one of my favorite things to do was, let's first annotate the data set with sentiment, because half the time we're actually going to not agree on the label. And then what I also recommend people do is, even if you're doing like a toy data set thing, trying out the new transformer library, just check the data first, because label errors are persistent. There's a website, labelerrors.com. I don't know if you've been. No, but the quick draw data set, according to their estimates, has a 10% label error. 10, right? I believe the Amazon Sentiment one has like 2% label error, and that's within the margin of state of the art. So it is just a hard problem. And again, the only cure that I know, or remedy I should say, is just the name of the game is iterating. Just every week you try to just have a meeting, and you make sure that the data scientist also labels, and the business person, and then you kind of go like, okay, let's look at the examples we got wrong. Okay, do we agree with the label that it was predicting? Yes, no, and loop. That's the remedy. But it's not easy. Like the modeling's the easy bit. That's just tensors.
Yeah, this is an extremely interesting topic, and I love exploring this application for Weaviate and how we can tie it into these active learning loops. And so here's how I see the picture of how Weaviate can help with this, and maybe you could add to what I'm missing. But so I imagine that we have some we're looking through our predictions, and we see, oh, this one has been mislabeled. Then we find the nearest neighbors to that one, and that's going to guide where we're going to go look for more mislabeled points.
So that's a tactic, and that's definitely not a bad one. One thing to keep in the back of the mind, the situation always kind of depends. Like, you might be interested in just sampling more from the rarest class, right? Like, that can also be a really good reason. So you just say, look, there's this one class that I'm really interested in, but it's kind of rare. Maybe sample more of those. And you can still use the nearest neighbor lookup trick, but just going to use it slightly differently. Another thing you can also definitely do is like, hey, let's just grab some of the examples where we have the most uncertainty, and let's grab more of those. There can be more than just one valid technique. The one thing that I do, the one thing I'm trying to sort of figure out, and I'm not there yet, is just what's the most pragmatic way to go about it? Because maybe sometimes you'll just want to do random. That's because I can imagine, for example, right? Let's say we're doing a social media thing, and I'm interested in finding texts that are about a failed delivery, like the customer complaints use case. okay, I might have lots of examples where I started out by just looking for the word deliver. If the word deliver appears in a sentence, it's probably about a delivery. And if someone is reaching out to customer service, it's probably a complaint. Okay, so that can be a very reasonable place to start. But then if you're going to look for neighbors that are very close to it, you're probably going to get lots of sentences that just have the word deliver in it. Those aren't bad examples, but it might take a while before you have a sentence with the word order in it. So okay, how can you protect yourself against that? Well, random is a thing that you could do. And just do it a bit randomly, make sure the search space is kind of covered. There are also like some fancier techniques where you kind of do a k-means thing first over your entire data set, such that you make sure that at least there's a bit of coverage, so to say. But this is also kind of the tricky thing with active learning. You do want to construct a test set that's not just because we were sampling this way this week and we're going to sample a different way next week. So but it is still a game of iteration. That is something that I do think is the pragmatic way to look at it. And one thing that I was pleased by is that there are many tricks of going about this, but having a nearest neighbor lookup is actually like a legitimate. That worked quite well for a couple of the tricks that I was doing, which is nice because not every trick works. It's nice that you find a trick that does work once in a while. It depends on how big your data set is as well. Like, I mean, if you only have 2,000 examples to start with, then you can probably brute force it on your laptop. But definitely the moment where you start hitting like the 10,000 and squaring that becomes a bit expensive. So that's kind of the time where you might want to start investing in the nearest neighbor lookup.
I think it's interesting also kind of the combination of the unstructured text or data like text or images with this metadata as well. And it kind of like what I'm imagining is I really, what you said to me about the idea that I'd want to do the nearest neighbor but look in the rarest classes, go hit the tail end of my data. And so that really stood out to me as being an interesting way to combine the nearest neighbor search with, say, symbolic filters about, which class is the rarest class. And you can add, and I don't mean to be too heavy on the features of Weaviate, but I love that part that you can combine nearest neighbor search with symbolic filters to say which clusters of your data, and you could use k-means to add the symbolic values of which cluster it's in to do that kind of thing. And yes, I think there's. Sorry.
So the general comment I have here is, in general, post-processing on a query is a good idea, and there are definitely many ways of doing it. Another simple way, like in the case of deliveries, you can also say, give me everything back that doesn't have the word deliver in it, but stuff that is actually kind of close, like it's another way. I'm not aware of the super symbolic feature you just mentioned in Weaviate, but I do, like, in general, I agree. Doing post-processing afterwards can be quite meaningful. That's definitely also a trick that's should be appreciated more. Because a lot of people just think, oh, I'm doing a nearest neighbor lookup thing, I got 100 items back. But then you can also still wonder, well, you don't have to go through all 100 of them, maybe. Maybe you just try to find the 10 most interesting ones in that, and then move on to the next item. Of course, depends on your data, depends on your task, etc. But give yourself the creative freedom. Like, that's the main point I'm trying to emphasize, I guess.
Yeah, really interesting. And Eddie and Dillacker has made something about pre and post processing in the symbolic filtering, and I'm not quite an expert on it, but if people are interested, I'll leave it in the link in the description. But yeah, this combining of nearest neighbor search and symbolic filters is very interesting for this kind of data labeling, finding problems in data labeling. So yeah, it's really interesting. So let me kind of pivot out a bit and ask you more of a broad question about this whole space of NLP. And I'm very curious, and something that guides my thinking is, do you have a particular application? And I do think the chatbot thing is extremely interesting, but do you have a particular application that you're usually focusing on developing, and then you kind of generalize these abstractions into developer tools like Spacey and so
on? So you mean personally or at Spacey professionally? Because I maintain a couple of personal open source projects as well. But my role at Explosion is a bit broad at the moment. So like one day I'm doing support tickets. The other day I'm doing open source stuff. The other day I'm doing a couple of PRs to fix a couple of bugs. The other day I'm making content. So it's at Explosion, my role is quite broad at the moment. But we also offer a consultancy service these days, and they are typically like to whatever problem a client has. And someone says, "Hey, Vincent, can we just Zoom it for a bit and like exchange ideas?" But I will say, like, in that realm of NLP, that we typically have clients It is a bit on the classification and entity detection, like those kinds of tasks. We don't do generative algorithms, I think at all. It's mainly like, hey, can we detect interesting substrings? And can we maybe say something general about this this bit of text about this document? Those are the typical things that we do. That's like definitely our specialty, so to say. And that's also where like our annotation tools can also kind of make a difference, because we have UI elements that are like really good for those specific tasks. So that's the most typical thing, I would argue, in the spacey realm that you see a lot of. But then again, because I also do a lot of stuff with Prodigy, like a lot of my work is also making interesting demos. The cool thing about Prodigy is, in the end, you can script it. It's just a Python backend, so you can make your own custom labeling interface and use whatever your favorite Python tool is. So part of my job in that realm that is actually interesting, I suppose, also like in the broader sense, is you can actually explore like what are cool annotation tricks that you might be able to do. And finding bad labels is one, for example. Like, hey, are there some tricks where we can automatically make a list of candidates that this might be a bad label? And again, you can use the nearest neighbor lookup thing where you can say, hey, the label of this one point is, let's say, class A, but all of its nearest neighbors is B. Okay, there you go. There's probably something fishy happening there. We should check that out. But that's kind of, if I can point at anything that's really fun about the job that I have, is a lot of the time I can actually make really cool annotation demos, and because I can use whatever tools Python can use inside of Prodigy, I can just sort of do neural, like basically anything that Python can do. And that opens up a lot of the doors. That said, the hardest part is usually what makes a good label. Like that's a qualitative thing as well. And that's definitely still the hardest part, I think.
Yeah. And then another questions, and maybe a little scattered now, but
Sure.
so what do you think about maybe like a collaborative data labeling interface? So like I share it with my team, and we all like, so it's like a UI, but all of us are together. It's kind of like, say, like Notion for data labeling, that kind of thing.
I mean, so depends on how you want to set up Prodigy, but the way a lot of people, like back in the day when I was doing demos and when I wasn't working at Explosion, the way I would just do it is, hey, data science class, we are about to do labeling. On my own local machine, I've got the server running, Ngrok, and it's now public, and people can sort of join in. So it's just a server. You can open it up on your mobile phone. And that's actually something, like there are these labeling workshops. It is my impression this is something that people actually do. Like, hey, team of engineers get together and they're going to say like, hey, we're actually trying to maybe build a new use case. We're going to do a sprint of a week, and day one is just going to be labeling. And then usually after labeling for a day, you kind of have you've seen enough data, so you also know some of the exceptions. And like, it's not necessarily Notion because it is saved in a flat file most of the time, but that, like, I hear stories that people are actually doing this. And one thing that I have heard, one story that I have heard that was actually kind of funny. There are lots of these examples where you start out with a use case where you're trying to do, I don't know, customer sentiment or something like that. But then after labeling, you find out that actually there's fraud in here too, because you're actually looking at like the raw logs and you're kind of going, that's not a customer, that's a bot. Where during the labeling, the use case can actually kind of shift because you are actually confronted with the data. That is something we've also seen. Those are stories that I have heard, let me put it that way.
Super cool. So the next question, well, quickly, let me ask you a quick question just to fill in my knowledge. Could you tell me a little more about Ngrok? Is that what makes it easy to create these, like web services from Python? Or how,
it's more like a tunnel. So it's basically like if I have something running on my local host on my laptop, that's great, but then you can't go to my local host. But then I can tell Ngrok, hey, just open up a little tunnel, and then Ngrok will then have a public URL, basically, and that's going to forward to my local machine. So for demos, it's really great. Not for production, by the way. Don't do it for production, but for demos and like showing stuff to the people locally, right? It's great. They have a free service. They also have a paid one. But especially for trainings and like just quickly sharing the labeling interface without having to worry too much about security, Ngrok is great. I can highly recommend it.
And that plugs nicely with, say, Google Colab, right? Where you can. Is that how? Like, I know, like Gradio, they give you like a temporary web address for your app when you run it in Google Colab. Is that how it's done?
Oh, I'm not aware. So I've never really used Gradio, and I'm also not the biggest Colab user. I have my own little Linux server at home that I prefer to use, but could be. I'm not so can't answer that properly because I've not used Gradio yet.
Yeah. Oh, yeah. Yeah. I'm just curious. I was when I was looking through SimCity, one of your projects that you're involved in, and I saw the way that you have that one line of code to set up the hosting, and I've generally been seeing this
Oh,
trend
but that's a
in
FastAPI server.
fast
So,
API.
so that's just a FastAPI server. For folks who are listening, some of the ideas that we are mentioning here, I made an open source project a while ago called Simsity. It's misspelled, so Simsity. It's the joke that I had was it's all about building your neighborhood, so that's why I call it Simsity. It's a bit of a hacky project. Like it's a brain fart that's pip installable, but it's not like I'm actively maintaining it. So feel free to play around with it, but don't expect support. Sorry. But one of the things that you're able to do, the goals that I had there just very quickly was that I was able to sort of do exactly what we just talked about. Here's a data frame. Here's a couple of columns. Here's how I wanted to encode. Here's how I wanted to index. Go. And then you could use all sorts of UI widgets from Jupyter Notebook, or just run it as a fast API server, and you'd have your REST endpoint, where you can just sort of say, hey, here's a JSON object with like a name, an address, etc. Give me back the 10 most closest neighbors. That whole part, it's the thing that it tries to automate.
And sorry, do you mind telling me a little more about FastAPI?
Yeah, so FastAPI is it's basically like Flask, but has a couple of more modern features that are quite nice. Now, I want to say modern here, and I do want to acknowledge like the Flask project has also gotten a couple of new features in. So both projects have their own pros and cons, but FastAPI is relatively fast, as the name implies. But it's just a very likable Python server that's really easy to set up. It is a bit newer, so one of the main reasons to maybe still consider Flask is that the plugin ecosystem is just a little bit more rich. But for example, FastAPI did have like async support right out of the box. I think Flask also has it now, but they introduced it last year, if I'm not mistaken. So for all intents and purposes, it's like Flask. It's a little bit more lightweight. And you get a bunch of stuff for free. So like the docs automatically generate, for example, for all your API endpoints if you add the doc string. But FastAPI is nice. If you want to make a quick web server such that other people can communicate with your machine learning app, FastAPI is a pretty convenient way to just quickly set something up.
Fascinating. Thank you so much for that. I'm really interested in the trend in these kinds of tools that are making it so if you're just like kind of a machine learning scientist, it's getting easier and easier to share your things with people, and yeah, these kinds of tools. So let me ask another. Sorry.
Well, I'm going to make a little pitch then. So I do also host this thing called Calm Code, which is basically like a learning center for like stuff that I made. The premise is it's like educational content, but not on YouTube. So I don't want you to get distracted. But if you're interested in Ngrok or FastAPI, I mean, there's free tutorials there. If people are interested in learning it, it's 2 to 5 minute videos. After watching for half an hour, you know how it works. So Ngrok, FastAPI, if you want to learn it, tons of places where you can learn it. But Calm Code, I've made a couple of tutorials. So if people are interested, those are for free. Please watch. They're great tools. They really are.
In addition to the quality of the content, I also have to compliment the quality of the styling on that website. It's got a really cool black and white icon thing.
Okay, I'll make another pitch. There's this project called the Noun Project, and I'm a paying member. It is the greatest service ever. For every single noun, they have a black and white icon, both in SVG and in black and white. It's amazing for presentations. The Noun Project is an amazing bit of software that I'm proud to pay money for. It is the best. And yes, every icon that I have on the Calm Code comes from that website. And I kind of just love how it has like a, Portal, the video game. It kind of has like that kind of a vibe to it as well.
Yeah.
But yeah, I don't want to take credit for those icons. The folks over at the Noun Project should. But Noun Project's great.
So on the topic of making content, can I ask you about kind of, I don't know if it's too into like your core strategy, but could you tell me about content strategy and how you think about that kind of thing? And
yeah, well, I mean, so the story is a little bit funny. Basically, the way I got into this whole content thing, I mean, I was definitely like a teacher before. So I taught calculus in university, and there's definitely like a teaching thing. I did that for clients back in the day. But the way I got started in this sort of content developer advocacy kind of stuff was I went to this conference called Spacey in Real Life. And when I went there, I had never done NLP before. But I figured, Spacey, cool project. If I go there, I might learn something about NLP. So you hang out with people, and I actually met Matt and Ines, like the founders of the Explosion Company, and you go to a bar. And at some point, I make a really bad joke. I go up to Matt Enos. I mean, I say the previous bar is really busy, but this one is nice and spacey. Spacey. Really, really corny joke. But apparently, from
So
my
you're hired.
perspective, I didn't get hired then. But what they told me was, Vincent, we think you would YouTube well. You know a little bit about data science. You're you have a good voice, and you're kind of funny. Would you be interested in maybe making some spacey content? And I figured, I can learn from like the two people spearheading this project, which is making a huge impact. If I say yes, I'm going to be able to learn from them. That's a pretty good deal. And I can give this whole YouTube thing a try. That's how I got rolling. But the deal that I did make is I didn't really want to become a YouTuber in the sense of click and subscribe. Like that felt kind of lame. I genuinely wanted to just make like a nice example, nice and tangible. Like if you want to apply spacey, let's just show how you can use it to solve a problem. And they were super on board with that as well. So there was like two hands on one belly, as they say in the Netherlands. But the funny thing then was I was making some of the spacey content, and then right around that time, people over at this company called Raza, they were interested in someone who could explain algorithms. And then they said, hey, Vincent, we like the style we see on the spacey thing that you've made. Could you do something like that, but for chatbots? So that's kind of how the ball got rolling. But the main thing I really care about is that I just explain things relatively clearly, and I think that's enough. I'm sure I don't mind if people follow me on Twitter, and I also speak at PyDatas, and I like it if the room is full, sure. But I get a little bit annoyed sometimes where you're looking at like a YouTuber trying to explain something in data science. There are plenty of really good ones, but but it has to be about the content. Like I really want to see like a really nice explainer. I love seeing when people have like, I found an interesting data set and this one trick works in that data set. I don't like it when people regurgitate the scikit-learn docs. That's the main thing. And it's also why on the Calm Code website, I don't want my face in it because I really want it to be about the content. Now, of course, I also make videos for Explosion, and we put that on YouTube, and we do want to have a coherent style. So there it makes much more sense that my face is also perhaps in the video. But my personal preferred style is to just have very calm content. That's the thing that I like most. And I'm trying to do that on YouTube as well. The only downside of the platform is that at every turn it does try to distract you with its recommendations. It's kind of a bit of a downside, I suppose. But I don't really have much of a content strategy besides I try to make good, interesting content by trying to find interesting examples. And sure, we have a content planning thing where if I've made a 40-minute long video, we do want to announce it properly, right? So yeah, we do that. But I really just try to find interesting content first. That's the strategy. And one of those, and one of the first things I made for Explosion was de-duplication. By the way, like how can you do de-duplication using Prodigy? Because one thing in general that I have observed is, I mean, Prodigy is great for labeling NLP tasks, but there's way more tasks, just like with these nearest neighbor lookups, that you can apply it for, and it really goes well beyond NLP. I mean, I can also imagine ANN being useful for some computer vision tasks. Like that wouldn't surprise me at all. But I get why there's lots of NLP content out there because I can also see those applications. But ANN stuff and also like the labeling stuff goes well beyond just NLP. That is also kind of the point I want to make with some of the Prodigy videos that I'm making there now. So yeah, long story. That's my strategy.
The last thing you said, so I do kind of want to talk about that a little more. The very last thing you said about the NLP computer vision thing. And sorry, but the story I found really interesting, and I actually kind of want to get into that a little bit more. So it seems to me like you're engineering by day, and then the problems you solve you turn into content, and that's kind of the way of thinking about it, rather than like the purpose of this is to make.
So for Calm Code for sure. Like I've not made content in months because I've not seen it. So. But I will say, like for Prodigy, it's a little bit different because for Prodigy, I am actually sort of actively looking for what would make a really cool demo to show off a little trick. So it wouldn't surprise me if maybe at some point I show off an approximate nearest neighbor trick, let's say, because that's something I'm actively sort of trying to figure out. And similarly, I'm also doing stuff with Annotator Disagreement because I'm pretty sure, like, if I just have a couple of data sets with really cool examples of Annotator Disagreement, then I can probably make like a good blog post or a video. Like the one thing, also like Calm Code and my personal blog, those are like my personal projects, and I really like having an off switch. But for Prodigy, I actually get paid for that, so that means that a good chunk of my week I can think about like what would make a really compelling example and what's like a really cool feature that we might be able to show off. So that I will argue like that there's a bit of a difference there in that sense.
Yeah, for me, this part of showing a really cool example is so much about finding a really cool data set. Do you agree
Yeah,
with that?
yeah, 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 for
Yeah.
sure. For sure. If you don't have a cool data set, uh, it's kind of like, maybe we could do a benchmark on uniform data. And you kind of go, yeah, I know. I could see why. But yes, technically you have a benchmark. It's just not a very interesting one.
Right.
So for sure, but finding a data set for sure is like one of the harder parts, though.
Yeah, yeah, and I love working at a database company because to me, it's like the algorithms, they're awesome, but it's like, let's find more data sets to hit this stuff with, like
Mm-hmm.
that kind of task of, I always find myself drawn to, let's go find a data set or let's build a data set, and that kind of thing always appeals to me.
Yeah, and it's also kind of the thing where you want to have a data set that's also not too small, not too big, right? So there's an interesting data set is also not necessarily a well-defined definition, but what you're hoping for is that you have a data set where you can sort of tell a story, where at some point there's a Luke Skywalker and a Darth Vader in your data set, and at some point you're trying to figure out like who wins, let's say. It could be, and I'm also like. I would like to do a little bit more with fraud data that's like access logs or something like that. I think that could be interesting too. Also, because there's going to be some sort of encoding you're going to want to have, maybe with some URLs and timestamps, let's say, but it's also not really NLP. It's structured text. But definitely for sure, you can do some interesting stuff there, I think.
Yeah, maybe quickly, I had some conversations about maybe turning structured data into text, like where you parse the table to try to turn it into text. And I know this is like horribly off topic, but what do you think about
Yeah,
that?
so I might have heard someone trying something like that. Never done it myself, to be honest. Like one thing, like especially when I talk about tables, like one thing I have also. Um, so a use case that I'm aware of is that they thought like, oh, we are going to be scanning documents and then we're going to do OCR, and then we're going to try to see what the values are in a table, let's say.
Mm-hmm.
And then you can kind of wonder, well, is that an NLP problem or is that maybe more of a computer vision problem, let's say? Because maybe you don't have to scan the entire document. Maybe you just need a pre-processing step that says, hey, where's the table, right? Right? So I do know a couple of people who are working in that realm. And also that's not necessarily a solved problem. Because with tables, you got to imagine, yeah, you got English, but you also have tables written in Chinese. So you also need to be able to handle those. And that's substantially different. The typical OCR stuff doesn't handle both Chinese and English at the same time. But again, a lot depends on what's the right label and what's the use case. That remains the same.
Yeah, that like document structure understanding thing, that seems like a booming application as well. You got the legal documents, maybe you got like invoices or
Biomedical
scientific
stuff,
papers.
yeah.
Yeah, really interesting.
Yeah,
Well, thank you so much, Vincent. I've been, yeah, I think
happy
we
to hear
really,
it. Yeah, happy to hear you found this interesting. Yeah.
yeah. Well, thank you so much for coming on the Weaviate podcast. I love talking about de-duplication, bulk labeling, and just all these topics. It's so much fun to chat with you, and thanks again.
Happy to hear it.